Hi, welcome to Ethereal Mechanics video number 30. This is going to be part 2 of video number 28 mixed with video number 29. We have an addendum that came about as a result of completing. So I made this an entire new video number. I'm pushing all the numbers back one. We're going to get into some heavy classical physics here and even some a little bit of basic electrical engineering stuff. So, but you know, the idea, with math aside, the ideas presented here are actually quite simple. Okay, and this is going to be a long video, so bear with me. I'm going to try to go fast. In this video, we're going to do the precession of elliptical orbits, specifically Mercury. And we're going to show that relativity uses the curvature of space-time to mediate gravity, and that's strange for me because I always thought gravity was the curvature of space-time. So this is really the mediation of gravity with gravity, so it's ridiculous. But they explained precession, but I found out something in modeling this is that they had come into an overunity condition, which causes the universe to be unstable because orbits become more and more elliptical, which means they're gaining energy. Eventually, the objects, everything in orbit will be thrown out of orbit, including galaxies. Okay, but in ethereal mechanics, viscosity also explains precession, and because of the viscosity, you do not get an overunity condition. It causes orbits to decay to circular. Explains why all bodies orbit in the same way around the central mass. We're also going to do an addendum to video 29 on black holes, which came about because of this. Okay, from video 28 part 1, ether has the fluid property of viscosity, or at least a property analogous to viscosity, enough that we'll call it viscosity for now. And the viscosity presents itself to us in three ways. Number one is drag. A solid object moving through the ether will eventually come to rest with the ether because of drag. But it's a very slow process. You may not even be able to detect it over our lifetimes, but it's there. Okay, this causes orbits to fall to circular. It causes a very small amount of negative precession. And the estimated KF, I really should have called this KD for drag, but whatever. The value comes out to 2.7 times 10 to the minus 5 for this equation here. The second manifestation of the viscosity is luminous loss. Light does not propagate forever. The loss is extremely small, but I'm pretty sure that what we think is at 14 billion light years away is really only about 7. And why is the Milky Way galaxy so dim in the night sky? I understand there's filth, but the parts of the Milky Way that aren't obscured by filth are incredibly too dark for being well, I made that point in, I think it was video number 5. And the third manifestation of the viscosity is fluidic resistance. Okay, if ether is flowing through a channel, then there's no converging forces. They move nice with a nice laminar flow. But you try to converge them into a smaller and smaller area, then they start bumping into each other, and then you get ether velocity components that are orthogonal to the direction of flow. Okay, and the way we can look at that is if we have ether converging on a gravitational body, and let's say, you know, this body just popped into existence. Okay, as they move in, they're all eventually going to bump shoulders and bang into each other, which is going to put velocity components not in the radial direction, but it's going to change some of that energy into the theta direction, as we would call that, in the theta direction. Okay, so but what happens is eventually, depending on which direction, one way there's going to be a little bit more energy than the other, and that's going to start setting up a rotation, a vortice, in a particular plane of axis around this body. And so now that you have ether particles coming in at an angle converging that way, when they finally bump into each other, instead of the direction of the angle of the collisions being, it's going to be more of in an angle like this, where those collisions occur, which is going to send energy into a nice swirl, and that's kind of, it's trying to show it there, but it looks like a mess. And that's where the ether whirlpool vortice is going to come from, which gives us the shape of galaxies. Now in Wiki, if you go to vortex, what they say about irrotational vortices is that in the absence of external force, a vortex usually evolves fairly quickly toward the irrotational flow pattern, meaning there's lots of different types of vortex flow patterns. It's the irrotational flow pattern, which is the one the ether ascribes to, is the one that is the most likely formation that you're going to get. Okay, also go to wiki Vorticity as opposed to vortex, and you'll see a nice animation for irrotational vortex compared with the others. So the basis is here for describing all of ethereal mechanics as a fluid motion, and these are some of the things I have to go through. The problem is we need more information about the ether first before we can do that, and we're going to get some more properties of ether when we go into the electromagnetic section, and then I'll come back and return to derive the fluidic flow models for ether. But for now, I need a simple analog to show that ether viscosity does interfere with the flow toward a massive body, causing a steeper gradient in the pressure to maintain uniform inward flow. And this is essentially what we were talking about in video number 28, is that under the normal model, the ether pressure, or the acceleration of the ether toward a body, and this would be more and more negative acceleration, that's acceleration toward the body. Okay, but because of interference, that acceleration has to increase to a steeper angle in order to overcome the viscosity friction. And this is essentially the same curve you get with relativity. This would be the standard classical line that you get from Newton, and this would be the correction line that you would get with relativity. So it's not a new idea that this would be a way you could get precession. But let's use electricity as an analog. Okay, electrical analog is very common. Inductance is the electrical analog of inertia, capacitance is the electrical analog of spring, and resistance is the electrical analog of friction, and in this case we're going to use it for viscosity. I have a picture of a Norden bomb site there. I was trying to look for an electrical analog computer. I found that. I put that there thinking I was going to talk about it. I forgot to remove it. That's an interesting, very interesting story there. So, in ethereal mechanics, anyway, we're going to show that everything in ethereal mechanics is a property. Every property of matter is electronic in origin: inertia, time dilation, gravity, etc. Okay, so this electrical analog I'm about to show you may actually result in a very interesting and correct relationship. And in fact, the results that I got amazed me. I was not prepared for the results, but they were very compelling. Okay, so here as we go along, for all those people who have wondered if there's a link between Coulomb's model and Newton's gravity model, because look, they look almost alike, except, you know, the form is almost identical. Hey, watch this. With nothing up my sleeves, you divide both sides, one side by the Q, one side by the mass. Okay, and so what we're going to do, because we're trying to make an analog for the acceleration of ether, and that's where I get the acceleration of ether, well, that maps directly to the electric field, which in a conductor we can map as dV/dr. This is the change in voltage as a function of distance from the central sink. And so don't confuse, we're going to use little case r for distance, radial distance from the center, and we're going to use big case R for resistance. Don't get those two confused. So here's the analog. Suppose we had a large ball of electric resistive material, and we coat the outside with a sheet of good conducting copper, and so the electricity can flow, the current can flow in, and then we put another copper ball at the center as a sink to pull that energy back out, such that the current at any current passing through any sphere will be the same no matter how big you draw the sphere at any given radius. Okay, so I is the radial ether flow, and R is going to be, we're going to model as a viscosity of the ether. So let's look at this. So we say resistance is equal to a rho times length over area. And since dr, the differential resistance of any given shell in this sphere, is going to be rho times the differential radius divided by the surface area at radius. Okay. And then we say that dV is equal to I times dr, so we multiply that by I. And then we want to get to dV/dr because that's going to be our analog for acceleration. And so we end up with rho I over 4 pi r squared. So if we we model, let pi, or rho I over 4 pi equal gm, okay, then our analog, dV/dr equal A is gm over r, which is, what we want to get to, which is a good analogy for, it's a perfect analogy for the ether flow toward a central mass that we derive from Newton's law. Okay, so now we have a good analog that tracks Newton. The Newton analog, which I say Newton's analog because a mathematical model is just a mathematical analog of a physical system. So we're using one analog to model another analog, not a big deal. Okay, and so if we use what we got just derived in standard, we should obtain all of the classical predictions with no problem. So how do we explain the precession of Mercury? Well, there is a small effect which we would normally ignore for most of our experiments because it's not big enough to really care about, except when you want to discuss something like the precession of Mercury. And so the resistance of metals increases as the temperature increases. And because the current density near the central mass is higher, you know, that little central ball at the center, well, I'm not going to go find it. The current is now gaining here, so there should be higher temperature around that little ball in the center where we're pulling the current out. And that ohmic heating should increase the resistance of the material, so we should see slightly more resistance. And because we have slightly more resistance, we should have a higher voltage drop. A higher voltage drop corresponds in our model to a higher increase in the acceleration of ether. So metals have a nearly linear change in resistance of temperature, so we're going to use the approximation that the resistance at any given little point in the metal is equal to some fundamental value, some initial value times a constant of temperature times temperature. Okay, now if we assume that the temperature of the material is proportional to the power per unit volume, okay, that's how we can determine the temperature from the current. Okay, if we say temperature is proportional to power divided by volume, okay, and we do this, this is a little differential area with a little differential radius from the center, and we go through all these calculations. I'm not going to go through them for you. Then we can come out that we can get an approximation for the temperature, which would be the current density times the value rho. So now we plug that back into this equation for temperature. We end up with this, and then we say that our current density is I divided by 4 pi r squared, and we plug this together, reduce some more, I'm not going to go through these. You can go through these on your own if you're interested. And then we get to dV/dr, and we de-analog it. Okay, now we're going to pull it out of the electrical domain back into the physics domain by replacing IP over 4 pi r with gm and dV/dr with a, because that's what we're looking for. And this now becomes our new ethereal mechanics model for the acceleration about a central mass, gm, corrected for thermal heating of the ether. Now, the reason why I wrote this way instead of this way is because it's a very intriguing answer. If you notice from our previous videos, that the tangential velocity of the ether about a rotating body is gm over r. Okay, this says to me, this is very interesting. Like our little example before with the little balls crashing into each other, and I may not have said it this way, but the energy of the ether going down the drain and colliding with each other is actually what fuels the rotational vortice, because it actually fuels, because now you have energy components that are not in the radial direction but in the theta direction. That energy will one day become coherent and self-sustaining. And this says right here that we're losing our energy, which is proportional to our tangential velocity. And this is a clear link, and I did not expect this result, that we would show that some of the energy, and we can look at it like a Pythagorean theorem. I look at it this way. Okay, if you multiply both sides by the bottom, you got the acceleration times radius minus this guy here is equal to gm. That looks like a Pythagorean theorem. Okay, and so in other words, this is what we need for our velocity of the ether coming in, or that's our velocity coming toward the center. This is the energy that's lost in the tangential area, and so the new radius of velocity that we need to make up for the difference is a bigger acceleration. Okay, and so I'm going to write this like this. This is the model I'm going to use for the computer simulation, because I get VT from another part of the code. So I'm just going to stuck VT to the cubed into that location there, because that's essentially what it is. An intriguing experiment would be if we took a disk of material, resistive material, I show copper, and we put a central point and we source the edges with current, and we drive it with enough current such that it heats the center. Would we see a rotational vortex? It should, according to the free vortices thing on Wikipedia, and according to this model here, we should see a rotation of current as it goes down the sinkhole there. All right, so now the inward. So what we did is this is what I can draw. And this is reason, and it's not unsimilar to what relativity had. It makes sense, from a standpoint that the viscosity should. And this is what we actually get. This is Newton's law as it was. This is now the corrected form that takes into account the viscosity heating, or whatever you want to call it. And that it looks exactly like what we predicted. Well, this is hand-drawn, so it's not as, this is more like what I was thinking. And this is similar to the curve relativity gets. So what did the computer simulation say? Well, what I first did, okay, is I set this guy to 0 and played around with this number till I got 43 arc seconds of precession between a orbiting Mercury and an orbiting Mercury that does not obey my reference Mercury, which does not obey the drag. Okay, so in my numerical simulation, I can't be sure of the precision, but if I have one that obeys classical theory and one that obeys the new drag, then the difference between them should be the precession that we would get with the numerical error removed. Okay, so when I did this, I set this guy to 0. This came out to be 3 times 10 to the minus 5. And then I kept changing this value till I got half of this eliminated. And this number came out to somewhere in between the 1 times 10 to the minus 20 and 1 times 10 to the minus 21. So I went looking for constants, and I found if I just took the quantum of circulation and divided by c squared, that this is the number I get. So I put this in. This is just arbitrary. I was just looking for, I'm sure this is part of it, because this is part of relativity too. So that's cool that that matches what relativity has. Okay, and this was just a number that had the value in the right order, and so I just used it. It's not a big deal. This has really may have nothing to do with it. Okay, just using physical constants to come up with a number that's in the ballpark. Then once I put this back in, then I kept dialing in this number till I got back to 43 arc seconds for the precession. So, okay, with these guys together, we get a nice precession of 43.1 arc seconds of Mercury, and we get a 1.1 part per million loss in the eccentricity, which means because of the friction, okay, the orbit of Mercury is driving toward a circular stable orbit. Okay, and we're going to go down to this one over here. Forget this guy for a second. We'll talk about that in a second. Now, if I set the, and this is the drag, and this is the viscosity heating. Okay, but if I set the viscosity heating to 0, okay, and just go with the friction, the drag, the precession goes negative, like we said in the last video, to minus 6.3 arc seconds, but we have a 1.2 part per million loss in eccentricity, and we're still going toward a stable orbit. So this drag is very important to get us a stable orbit, because if I set the friction or the drag to 0, okay, which would be almost the same thing relativity would predict, we get, 49.4 arc seconds, but we get a 0.2 part per million gain in eccentricity, a gain in eccentricity, which means we're unstable, which means that planet Mercury would continue, and that blew me away, because that means relativity does not predict the drag like ethereal mechanics does, and therefore if we have a gain in eccentricity, a gain in orbital energy, that means these planets would normally be thrown out of orbit. How long, I don't know, but they should not be having nice stable circular orbits. Any wobble in their orbits would be magnified, and these planets would eventually be thrown off. Galaxies wouldn't have a nice simple rotation. They'd be thrown, the galaxies would be diverging. So relativity is unstable. It has overunity. You need the drag. And the cool thing about ethereal mechanics is the drag gives us both the precession and the drag. So it's, it gives us the energy, but it takes it back in the form of drag. Okay, and this is what I just explained. Here's for both ethereal mechanics and relativity say that gravity gets stronger as you close to central core. This explains the precession. However, these are both overunity conditions. Okay, and remember, this is something over c squared, and there's the c squared that Einstein predicts for this. And you also notice that ethereal mechanics considers the mass of the little, relativity considers the mass of the little planet, where ethereal mechanics does not. But anyway, the point is that ethereal, okay, but if you think about this, the precession requires that you pull the planet in tighter every orbit, right? So if you got your planet coming in and you pull it tighter to make it precess, okay, you're going to be adding more energy to the planet. Okay, so eventually, according to relativity, without the drag, or ethereal mechanics without the drag, all planets will eventually be flung away. This is not the stable environment we see. Only ethereal mechanics provides a drag model which asserts that orbits decay to lower energy circular orbits. Okay, I'm not going to read this for you. You get that? So to recap this, ethereal viscosity provides the drag on bodies moving through it, which leads to orbital stability, provides the energy to drive the ether whirlpool, which gives us a stable rotating reference frame in which planets and stars can be at rest and still be in orbit, and it also provides the increase in gravitational force near the central mass to explain the precession of Mercury. So the ethereal viscosity explains all three of these things. It's all nicely tied together. And that's just from the analog model, the electrical analog. So, and here's another comparison. So relativity explains precession, but it gives you overunity, and orbits diverge because they're increasing eccentricity. The mass of the little planet is part of the equation, and in relativity, mass is king. Okay, in ethereal mechanics, explains the precession without overunity because orbits decay because of the drag. Okay, and mass of the little planet is insignificant. Ether is king. Mass is like confetti in a river. Okay, in other words, we don't consider the mass of the little planet because if you are accelerated by ether inertially, just like if you look at the Galileo experiment, where the force of gravity equals k m1 m2 over r, where you divide by one of the masses. Your acceleration is now independent of your mass. It's only dependent on the mass of the bigger planet that you're standing on. Okay, that's the way it should be. Your motion is dictated by the ether. Because remember what we said before, that mass is a little tiny contamination to the ether. So your mass should have very little to your... In other words, the ether is going to carry you along no matter what you're going to do. So your mass should not be part of the equation. Okay, and you can read the rest of this. Okay, so now let's break over to video number 29. It was 2 thoughts about black holes that came to me while working on this precession viscosity model. Okay, when black holes form, there should be a tremendous energy burst. Maybe that's a gamma ray burst, I don't know. And under certain conditions, black holes may actually pulsate. Because remember what we said before, when a star collapses, a star will consume ether, before a star collapses, a star will consume ether proportional to its volume. It's basically the cube of its radius. After it collapses, it only consumes ether proportional to its surface area, which is the square of its radius, but it's much, much smaller. So we go from this, which consumes ether based on its volume, to this, which consumes ether based on its surface area. And therefore, that sudden stop of ether should create a tremendous shock wave. The analog with this be if you had a wide open faucet and shut it off quickly. You notice how the shock wave would rattle all the pipes in your house. And because it's a sudden stop, the spectrum of the event should be broad. Okay, there's another one thing for the ether event, the inner event horizon. Because of viscosity, there's an inner radius at which black hole will not be able to adequately feed. If the black hole radius falls below this inner radius, it may possibly reinflate. After reinflating, ether flow will be reestablished and it will collapse again. Is this a pulsar? I don't know. This is just conjecture. Here's a little bit about simulation of the details of the simulation in case you want to do it on your own. These are your ethereal mechanics models that were used. This is the drag acceleration. This is the acceleration of the ether. The acceleration of your object is the acceleration of ether plus the acceleration due to drag. Okay, the mass of the sun I used was 2 times e to the 30 kilograms. The distance initial distance for Mercury at aphelion, I used this number, and the initial velocity was in that direction. The difference in time, the delta time I used was 1/10,000th of the period of the orbit of Mercury. Okay, and this is a snippet of the code. This uses a midpoint method, and I just got to explain a little bit here. First, I come in and get the midpoint time, and I calculate my location, where I'll be. This is a vector, my position at the midpoint, and this is approximate position. Then I get the ether motion vectors from that. I call out to the code, and it computes all the ether motion from all the different contributors. In this case, it's just the sun. All right, then I get my acceleration, and I compute an initial velocity using velocity plus acceleration times time, and initial position, a new position, position 2, which is position plus velocity times time plus 1/2 at squared. Okay, once I get this new velocity, I take the average of the new velocity and the previous velocity, subtract that from the ethereal velocity at the midpoint to get the v difference to compute the friction. Then I add the frictional acceleration to the acceleration that I got from the star, and then I recompute my velocity. Velocity equals acceleration times time, and my new position, my original position, plus my original velocity times time plus my new acceleration, 1/2 at squared. Okay, and what I do is there's a pre-process. In other words, we go through all the objects in pre-process, and once everybody's got what their new position and velocity will be, then the next process we just go through all the other objects in the universe and pop the new positions now become the previous positions. And I have the vector class that I made. The bang sign is the magnitude, star is the dot product, percent is a cross product, and the tilde sign is the direction of. And in this particular thing, KED is KF. This is K electrical drag, or ether drag. That's really what I should have called it in the slides. Okay, recap. Relativity cannot be right because its explanation of the precession of Mercury causes an overunity conditions. Planets would have been thrown off by now. And ethereal mechanics provides a simple classical explanation for precession without overunity. And relativity is dead. In video 22, we demonstrated that general relativity violates the solution to stellar aberration that we got from special relativity. And ethereal mechanics provides a classical solution. In this video, general relativity's gravity-mediating gravity explanation leads to overunity and unstable universe, where ethereal mechanics provides a simple classical solution. So, here's my ending slide. No more voodoo physics. This is Albert Einstein as a voodoo witch doctor. Please get the word out about these. Give me likes, and if you can donate, I'd really appreciate it. Go to my website. There's a donate button. My website is completely outdated. And this is a Calvin and Hobbes cartoon I really like, but I got to get going. This video's getting too long. Bye.